All right. Let's begin. So, before we begin today, I want to prepare your minds. Many of us have walked in this room with a closed mind. You guys think you're tomorrow's future with open mind, ready to accept anything that's new, right? But you're not. You're not. Let me tell you what, everybody's got their own biases, and so I'm gonna share you a history about some biases, okay? Did you guys know that when negative numbers were first conceived of, there was like, people were like offended and like bothered that somebody would dare suggest that numbers could possibly be negative? How could you have -1? There's no such thing as a -1 chicken, right? But negatives mean something, don't they? Like, for example, what about when you owe money? How about when you owe money, right? If you owe somebody money, then you have negative whatever amount of dollars. So you can represent things in real life by these concepts of negative numbers. And so people were kind of closed-minded to this idea, but it turns out they're actually useful. I'm going to share with you guys something today that seems like it's really cheating. And it seems like, are you really allowed to do that? And the answer is yes, you can. So here we go. We're going to talk about something called an imaginary number. Now, I want to clarify something. Imaginary doesn't mean fake, okay? Imaginary means not real. Now you might think, isn't that the same thing? It isn't, because in mathematics we have a certain group of numbers that are called the real numbers, okay? And all that imaginary means is that it's a number, but it's just not it's not the real number set. So just understand, it's a different kind of number, basically. I know. So let me help open your minds a little bit more. So I'm gonna ask you guys to tell me, what is a number? I'm not looking for an example. I'm looking for the definition of a number. What is the definition of a number? That's like saying potato. I need more.
A number is a part of a numerical system that is used in a speech.
Go ahead, Rowan. That was nonsense.
I'm just confused as to what he said, because now I forgot what I'm going to say.
Okay. Anybody?
Okay.
You're
A
welcome.
concept used to measure the amount of something.
Okay. So something, some way to measure something, right? Quantitative. Okay, so it's an amount. It represents an amount. Anything else? It's a symbol. Very good. Thank you. Okay, so we have a couple of things here. I want your peers have said some really good things. Quantity, amount,
It's a weird shape.
measurement, and symbol. Now, guys, if I put this on the board, what is that?
A weird shape.
That's a 5. That's not a 5. Do you guys know what that is? That's a scribble that you've been trained your whole life to understand represents a concept which is in your brain called 5. So that's not really a 5. Do you guys want to see a 5? A real 5?
F-I-V-E.
There's 5 things right here. Right? That's a real 5. Okay. This is a picture that we've agreed represents this thing here.
Actually,
Okay.
you're so wrong. Because we've also been trained to believe that this is the number 5. For all we know, this could be like 6 or something.
What?
We've been trained to believe that it's 5.
That's
How do we
wrong.
know that we know 4?
That's wrong, because this is across the world. If you were to go to an alien, now Jonathan, students learn by listening. Now, here we go. If you were to stand on this planet, I could give you a different word to represent this concept. I could call it 5, I can call it cinco, but we both know what we're talking about. I could go to another planet with an alien that doesn't exist, but let's say an alien exists, I can say, what's this? And he'll go, "Arr." And he knows what 5 is. But if I show the alien this, he's going to go, huh? He doesn't know what that means. He hasn't been trained about this symbol, but he knows what this means. So this is an objective reality. This is nothing. This is a symbol.
It's called visual learning.
How do we know he was right?
There is no such thing as a right name. Names are arbitrary. Like your parents could have called you Quijibo. But they didn't.
What is
Quijibo is a fat, balding ape. And the reason that's in my head is because I just watched The Simpsons for the first time in like 15 years, and they say that on it. So, not that I think you're a fat, balding ape, but go ahead. See, that's just another symbol. But let me ask you this, LaFontaine. She said, LaFontaine said this, you guys. She said, what about this? That's a 5. But don't you think the Romans means the same thing as this?
Yeah.
They just use a different picture, right? So, here's what I want you guys to walk away from with this discussion. Numbers are a quantity that represent an idea in our brain, and we represent them with symbols. So I need you guys to understand what numbers are before I share this idea of imaginary numbers with you, because otherwise you're not going to believe me that what I'm sharing with you is a real number today. All right, go ahead.
I had a really bad joke with the Roman numeral thing.
Go ahead.
And then you went and said that they would just use the same hand thing. I'm going to say it anyway. A Roman walks in and held up 2 fingers and he says, 5, please.
Yeah, I like it. All right. I saw it coming. I heard you. All right. Okay. So now, some of you guys, especially those of you guys who are really strong with your math, I'm about ready to offend you, okay? But I want you guys to pause for a second. I want you to see if you can solve it. Go ahead. See if you can solve it.
You can't.
Okay, what is it? What is it? Go ahead, Michael. Okay, I'll take it. X equals 1.
Or -1.
Good. Let's see if he's right. Ready? He got x equals 1 and -1. You ready? So 1 squared minus 1. Is that 0? Yep. 1 squared is 1. 1 2 1 is 1. So how about this one? How about -1 squared minus 1? Is that true?
Yeah, it is.
It is. So he found both answers. The answer is 1 and -1. So far, Mike is like my mathematician who decided he wanted to solve this following problem.
Why is it -2?
Oh, because I had a moment.
What did you write?
What should it be?
I almost set up my copy.
In my hair?
Okay, ready? Let's continue my story. So Micah did it, and he felt pretty good about himself. Okay? But then, Mr. Bailey comes along and tells Micah to solve that. I'm going to calibrate my board while you guys are thinking. But I need you guys to find out what the x value is there. What squared plus 1 would equal 0? So here's the deal. Here's the deal. Ready? Mike is frustrated. It didn't work. And then he got a little angry. But then he got to thinking. He's going to cheat a little bit. Let me show you why he's angry for those of you guys that aren't tracking with me. First of all, here's one way to solve it. Do you guys know how to get rid of that? You got to take a square root. Here's the thing. When you take a square root, you're basically asking yourself, what number times itself makes that number? Well, what number multiplied by itself is a -1? Well, that's impossible. Let me show you why. What is a positive times a positive? And what's a negative times a negative? So no matter what kind of number you pick, if you multiply a number by itself, it always comes out. So therefore, there can't be a square root of a -1, because there is nothing times itself that will ever give you -1, right? But mathematicians sometimes, believe it or not, can be a little bit creative. So we're going to go back to our story here about the mathematician. At first it didn't work. Gets a little bit angry, and then he got to thinking.
Oh yeah, I'll get.
You ready? I'll just invent a new number.
What's I? Oh my gosh.
Isn't that offensive? I'm just going to invent a new number. It says, I'm going to call it the imaginary number. And I is the square root of -1, and therefore now I have an answer to my equation. The answer is I, the square root of -1.
So you have to.
Now let me ask you this. Is this a symbol?
No.
Yeah. Yes.
It is a symbol. And doesn't it represent an idea in our head?
Yes.
Just like every other number in the world. Well, it's not the same kind of number. Okay, now, I don't like their choice of words and saying real versus imaginary because that makes people think that these numbers really exist and these numbers don't. That's not what they mean. What they mean is that this is one group of numbers that we're going to call the real numbers. This is another group. Now, somebody might think, well, that's stupid. You can't just do that, right? Maybe not. Here's why. Did you know that negative numbers were not always accepted as real numbers also?
Yeah, you
But
told
now
us.
we know they're real, right? Right? How about this? It actually turns out that this is a number anyway. It's just a symbol that represents an idea like all other numbers. And then finally, guess what? It turns out imaginary numbers help us solve problems in physics and science. Whoa, crazy. So, weird stuff. So we're going to invent a new number today. It's called an imaginary number. Weird stuff.
It was already
Well,
invented.
what if it's not precise though? Like, it's the imaginary number. I'm so confused. Like, if it's not the answer, but the answer is the imaginary answer, how do we know if it's precise though?
Yes.
Like say like going to the moon, right? What if they had to use imaginary number, but what if it's like it's not precise though? Like, you know what I'm talking about?
You're talking like a real mathematician there. Mathematicians don't just make things up. They define things very clearly. And so that's going to be part of what we're talking about here. But let's go back to our problem here. Remember this? Remember that? So let's see if let's check to see how precise this answer is. I'm going to put the square root of -1 in there. Now, according to our already precise math rules, what do squares do to square roots? Works pretty good. Works pretty good.
I think I've done that
Right.
before. I canceled out a square root before. But then, why do we use imaginary numbers? What?
So we can have an answer. And once again, this also created some issues when people don't like that kind of stuff. They're like, you can't do that. But it turns out, like I said, it actually helps us solve things in physics and science. It's pretty interesting. So we'll leave it at that. Personally, I don't think that the controversy over imaginary numbers is completely solved yet, but they are useful nonetheless. Hello. Yes. So here's the deal. Here's your definition. This is that precision that Henry is talking about. I'm going to say that this is I. We're going to invent this new number, and I'm going to define it as the square root of -1. And we have to say this also, that I to the second power is -1. Because don't square roots cancel out squares? Okay? Now, the reason why this is actually important is because if they didn't include this in the definition, you might have a problem. Can I show you? What if we had this, right, and we squared it? Now, there's two ways you could solve this. One way would be to do what I did earlier. Those cancel and you get that. That's a good math rule. It always works, right? But what if somebody did this instead? Right? And we have another math rule that says we could do this, right? But what's -1 times -1? And what's the square root of +1? So what's the answer? 1 or -1? To avoid that confusing stuff, they said this is not going to be the answer. This is. So here's the deal. I is the square root of -1. I squared will be -1. Okay? And if they didn't define it this way, remember that problem the math teacher was working on earlier? That we wouldn't get the right answer if this wasn't true, so it has to be this. So there's your definition of this new number. Okay? And today our goal is we're going to do a couple things with this new number. We're going to learn how to simplify expressions that have this number in it. We're going to learn how to multiply numbers that have this imaginary number in it. And also, I'd like to get to rationalizing. There's more of that. All right. So,
Hang on.
but you'll find that everything we're learning today is really just a repeat of what we learned, I think, last time, just with this new letter involved. Because it's just square roots, right? It's just square roots. All right, we good?
No,
Freaking hand. Freaking.
I will write school.
Do you know who invented the imaginary number?
Actually, I don't.
Was it like back, or was it like recently, like in the 20s?
My guess is it was probably like in the 1800s, but I could be wrong. So you look it up on. No, I don't want you to. We'll look it up later. I'm curious now. Okay, go ahead and write down example 1, number 1, please. Our first slide is going to be about how to simplify expressions that have imaginary components to them. Now for the first problem, I'm going to show you the long way, and then I'm going to show you the short way, and after that we're going to use the short way. But the long way helps us understand why the short way works, okay? But after that, we're just going to do the short way, because it's much easier. You ready? Okay, so here's the long way to simplify this expression. Remember last time how we wanted to separate the rational part from the irrational part? Remember how last time we wanted to separate rational and irrational?
Yes.
Today we want to separate imaginary from real. Okay?
That's the big
Not that bad, trust me. If you guys got last class's lesson, this won't be too bad for you. Are you ready? All right. So here we go. Long way first, and then I'll show you the short way. Ready? So here's the long way. -5. Don't you agree that's the same thing as -1 times 5?
Yeah.
And we have a rule about square roots that says anytime you have two pieces in a square root being multiplied together, that's like two square roots just being multiplied separately, correct? And we have a definition for this. What did we call that? Good. And what do we abbreviate it as? And we're done.
Wait, what?
That's
What's
it.
that? Oh,
I'm just separating the imaginary from the real. Okay?
Wait, hold on.
Now that's the long way, and now I'm going to show you guys the short way.
That's the long way?
That's the
Yeah.
long way?
Yeah.
That's the whole lesson.
No, that's not the whole lesson, but that's how we separate real from imaginary.
I need everybody to shut up when he does this, because this is crazy.
Okay, you guys ready? Here's the short way. Cross that off and put an I in the front. Okay?
Oh my god.
All right.
Nice. Very nice.
So if there's ever a negative inside of a square root, just drop the negative and put an I in the front. Okay?
What if it's not a negative?
Then it's not an imaginary number anymore.
But then, won't you get mad that we're not showing work or
Nope,
something?
not for that.
Really?
Mr. Baby.
Not for that. No. Yeah.
So we do this for any number that can't be factored out. How is the
You do it for any number. So let's move on to number 2, and I'll show you. Ready?
Can you do the old short way?
Write down number 2. I'm just going to do the short way. Ready? So the first thing we're going to do, you always do this first, is take out the I. So we're going to cross that off, and we're going to put an I in the front, right? That's important, because now that I've separated the imaginary from the real, now I can just treat this like I always have. What's the square root of 9? So now my answer is 3i.
Oh, wait, why don't we put I3? Why don't we put I3?
Why can't you just
Does the order matter? So that's a good question. Somebody asked, does the order matter? So I'm going to answer that. Ready? When you have a square root, it's normal to put it in the front. Because if you put it back here, some people might think, is that under the root or is it not? That's confusing. So when you have a square root, we like to put it in the front so we know that it's not. But when you don't have a square root, like just a number, technically you could say I times 3, but do we usually put letters in front of numbers in algebra? No, it's the other way. So that's your answer there. So I would give you full credit either way, but just so you know what your answer should typically look like. Okay, let's do one more here. Go ahead and write down number 3. So the point here is to separate the imaginary from the real and then treat the real part just like we did last time. So most of today is just going to be a big review of square roots. Most of today. Ready?
Wait, does this get harder?
Is this what it goes on?
Yeah, maybe. Let's see. All right, so what's our first thing we have to do, guys? Take out your I. Now what? Break it down.
Oh, wait.
Now what? Find your pairs. When a mommy turtle and a daddy turtle love each other very much, they have a baby turtle and then they leave. So we have 2i root 7, and there's my final answer. So it usually comes after the whole number, right? And then in front of the square root. Notice this thing has 3 parts to it. It has a rational number, it has an imaginary number, and an irrational number. Got all 3 of them. That's how we simplify with imaginary numbers. Okay? Clear? Oh. All right, I'm gonna throw these at you guys and let you guys practice them, right? And we'll see how you guys do. Try these. I'm sure she'll appreciate it. Okay.
Wait, hang on.
Any other questions before we move on? Number 1.
Hang on. It went like that.
So, Kayla, for number 1, we did this first, right? And then we break down the 8, which you should have gotten 3 2s for. Take out a 2. You got it. The only other one we didn't go over was number 3. All you do is you take out the I. You can't really take anything else out because there's no pairs in a square root of 10. So it's just I square root of 10. Anyway, so there's your student practice. That's simplifying. Now we're going to move on to multiplying with these things. Yes?
Will you have credit, like, for example, for number 1, if you put I8?
If it's a written part, yeah, but if it's a multiple choice, they probably wouldn't even have that as an option. Okay, let's go ahead and proceed. Go ahead and copy down example 2, please. Copy down example 2, please. So, here's the thing. You want to start by doing what we did before. Take out the I. So the first one's going to become this, right? Pay attention. The next one is going to become this. Okay? So on every I, in every problem where you have a negative beside the square root, you have to start like that. Okay? You can't skip that step. Always take out the I first. Now 5 doesn't simplify. That's it. That's an irrational number. So we're done with that. But let's go ahead and put these together. What is I times I?
I squared.
I squared. And square root of 5 is being squared also, right? Because you're multiplying it by itself. Okay, now, what do you get if you take the square root of 5 and you square it?
Positive 10. Oh my, sorry, 25.
You get 5.
Wait.
Because a square cancels
What's
out
that
a
dot
root.
for?
A square cancels out a root.
But look, the I squared.
Now let's talk about the I squared. I told you guys earlier today something about I squared. What does I squared equal?
Imaginary. -1.
It's a real number. It's -1.
And then -1 squared would be positive.
And what's -1 times 5?
Whoa.
Okay, so here's your steps, you guys. Always take the I out first. After that, just follow all your old math rules, but don't forget I squared is -1. Yeah.
So you mean to tell me all
Because that's part of the definition. That's how mathematicians decided to define it. All right, go ahead and write down number 2, please. Write down number 2, please. All right, here we go. So you guys agree that this means 6i times 6i, right? Square means you multiply something by itself, correct?
Yeah.
That's right. And that's what it means. So it just means you're going to square this whole thing. You're going to multiply the whole thing by itself. Now, what is 6 times 6?
36.
And what is I times I? And what is I squared? So therefore my answer is?
Wait, what?
Okay, but oh wait, okay.
Okay, last slide, guys. I think. Here you go. Work these out really quick. Number 1, -4 times -4 is 16. I times I is I squared. And I squared is -1, which means my final answer is -16.
Wait, what is that?
Number 1. And number 2. I'll work the rest out. If you guys want to go home and watch the video, you can, or if you want to stay, you can. But I'll work them out. You're welcome.
Last time I stayed with Hannah, my mom, my sister.
Sue, thank you.
I mean, I'm enforcing pain, but you
Like it's
Oh, yeah, obviously. When you did all the whole summer. He was gonna be like, breakfast, lunch, and
Henry,
yes. Oh yeah.
don't go.
I'm gonna wait by the door.
Amen.
Come here.
Wait, are you taking me home?
Yep.
You taking me home? Oh, you're not. He's bringing me.
So, Riley, what would be a good time to do the test? To come in this week?
He said Thursday.
You tell me a day that works for you, and I'll just let you know if I'm here. I'm usually here every day. The only one that I'm kind of sketchy on is Wednesdays.
Thursdays?
Thursday, oh yeah, Thursday's Bible Club, so I'm a little bit unavailable there. But you can come in on Thursday. It's just that
Friendly Bible
it might
friends.
be noisy. So. Okay.
Wait, so